A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Imagine an AI agent that can browse any website, fill out forms, and click buttons just like a human, but without a visible screen or a hand on a mouse. It sounds like a ghost in the machine, but it is actually the backbone of how the modern web is being indexed, tested, and now lived in by artificial intelligence.
It is the browser layer for machines, Corn. We are moving away from the era where browsers were just windows for human eyes and into a period where they are the primary sensory organs for AI agents. Today's prompt from Daniel is about the headless browser ecosystem, Playwright, Puppeteer, Browserbase, Steel, and how this infrastructure is becoming the critical bridge between static LLMs and the live interactive web.
By the way, today's episode is powered by Google Gemini 1.5 Flash. I'm Corn, the one taking it slow and steady, and joining me is my brother, Herman Poppleberry, the man who probably has 17 headless Chrome instances running on his laptop right now just to check the weather.
Only 15, actually. But you raise a good point. To understand why this matters, we have to define what a headless browser actually is. Essentially, it is a web browser like Chrome or Firefox, but it lacks a graphical user interface. There is no window, no address bar, and no back button you can click. Instead, it is controlled entirely through code. You tell it to go to a URL, click a specific selector, or scrape the text from a paragraph.
So, it's a browser for robots. But developers have been doing this for a long time, right? This isn't exactly brand new tech. I remember people talking about Selenium back when I actually had a decent sleep schedule. What has changed to make this a hot sector again in 2026?
Speed, reliability, and the agentic turn. Selenium was the pioneer, but it was notoriously flaky and slow because it relied on an external driver to talk to the browser. It was like trying to drive a car by shouting instructions through a megaphone to someone else in the driver's seat. There was a lag, and things got lost in translation. Then Google released Puppeteer in 2017, which gave developers direct control over Chromium via the DevTools protocol. It was a direct nervous system connection. Then Microsoft released Playwright in 2020, which upped the ante by supporting not just Chromium, but also Firefox and WebKit with much better auto-waiting logic. If a button hasn't loaded yet, Playwright waits for it instead of just crashing.
Right. The flakiness was the big killer. You'd write a script to buy a concert ticket, and it would fail because a pop-up took 200 milliseconds too long to appear. I remember trying to automate a simple login once, and if the CSS changed by 1 pixel, the whole script would have a nervous breakdown. But now, we aren't just talking about scripts, we're talking about AI agents. Daniel's asking about the shift toward browser as a service. Why can't I just run Playwright on my own server and call it a day? Why do I need a company like Browserbase or Steel?
Because running a browser is a resource nightmare. Chrome is a memory hog for a human. Imagine running 100 instances of it on a server to power a fleet of AI agents. You hit a wall of RAM and CPU usage almost immediately. Each instance needs its own sandbox, its own memory allocation, and if one crashes, it can take down the whole node. But the bigger issue, the one that Daniel really wants us to dig into, is the cat and mouse game of bot detection. If you run a headless browser from a standard data center IP, like an AWS or Google Cloud address, many websites will instantly block you. They see a headless signature coming from a server farm and say, nope, you're a bot.
Ah, the classic access denied screen. I've seen that more often than I've seen the sun this week. So, If I'm an AI agent trying to, say, research local real estate prices in Tokyo while I'm physically sitting in a data center in Virginia, I'm going to get flagged immediately. It doesn't matter how smart the LLM is if it can't even get past the front door of the website.
Well, not exactly, but that is the core of the problem. If you use raw Playwright on a local machine or a basic server, you are effectively a loud, clunky robot walking into a high-security building. SaaS platforms like Browserbase and Steel provide the stealth suit. They handle the infrastructure, but more importantly, they handle the identity. They manage the fingerprint of the browser.
Explain fingerprint to me. Because I always thought if I just changed the user agent string to say I am a totally normal human on a MacBook, the website would believe me. Is it really that easy to lie to a server?
It used to be, but in 2026, anti-bot services like Cloudflare, Akamai, and Perimeter X are incredibly sophisticated. They don't just look at the user agent. They look at canvas rendering, how the browser draws a hidden image. Every graphics card and driver combination draws a single pixel slightly differently. They look at WebGL signatures, which are unique to specific hardware. They check your hardware concurrency, how many CPU cores the browser reports having. If you report a MacBook user agent, but your WebGL says you're running on a Linux server with an NVIDIA T4 GPU, the site knows you're lying.
So it's like a detective looking at your shoes and realizing they don't match your tuxedo. You're claiming to be a billionaire at a gala, but you're wearing scuffed up work boots.
That is a perfect way to put it. Platforms like Browserbase or Steel do fingerprint spoofing at the browser level. They intercept those low-level calls to the hardware. When the website asks, "What kind of graphics card do you have?" the platform ensures the headless browser answers with a convincing, consistent lie that matches the rest of its identity. They rotate these fingerprints so you don't look like the same robot every time you visit. They even mimic human-like font lists and screen resolutions to make the profile look organic.
Okay, so that handles the who you are. But what about the where? Daniel brought up geo-restricted content and residential IPs. If I'm trying to bypass a region lock, maybe I'm an agent trying to find the best flight prices that are only available to users in the European Union. How do these cloud services handle that differently than me just using a VPN?
VPNs are easily blocked because their IP ranges are public and associated with commercial data centers. What these browser-as-a-service providers offer is integration with residential proxy pools. These are IP addresses that belong to actual home internet connections, Comcast, AT&T, Verizon users. When your AI agent makes a request through Browserbase, it looks like it is coming from a real person's living room in Paris or Berlin. It carries the reputation of a home user, which is much harder for a firewall to block without risking blocking actual customers.
That sounds expensive. And a little invasive, if we're being honest. I mean, someone is getting paid for their home IP to be used as a relay. But I guess if you're a developer building a high-end AI researcher, you can't afford to have your agent get blocked by a not available in your country message.
It is expensive. Residential proxies can cost anywhere from $5 to $15 per gigabyte of data. But for an AI agent that is just scraping text or performing a specific action, the data usage is low enough that it is worth the cost to guarantee access. This is where the competitive landscape gets interesting. Browserbase recently raised $10 million in their Series A back in January, and they are positioning themselves as the infrastructure for AI agents. They aren't just giving you a browser, they're giving you a session.
Session is a key word there. Usually, if I run a script, it opens a browser, does a thing, and then closes. Everything is wiped. But if an AI agent is supposed to be my digital twin, it needs to stay logged into my accounts, right? It needs to remember that I'm already signed into my bank or my email. If it has to log in fresh every time, it's going to get flagged for suspicious activity.
This is the session persistence problem. If you run Playwright locally, you have to manually manage cookies, local storage, and session tokens. It is a massive headache. If you lose the state, you have to log in again, which triggers two-factor authentication, which usually kills the automation. Browserbase and Steel allow you to pause a browser session in the cloud. The state is saved, not just the cookies, but the literal memory state of the browser. The next time the agent wakes up, it resumes that exact same browser profile as if it never left.
I like the idea of an agent being able to hand off to me. Like, if it hits a wall where a site is demanding a 2FA code from my phone, the agent can just say, "Hey Corn, I'm stuck at the login. Can you hop in and type this code for me?"
That is exactly what they are building. They call it human in the loop or pause and resume. You can actually open a live view of the headless browser running in the cloud, see exactly what the robot sees in a real-time video stream, type in the code, or solve a tricky captcha yourself, and then let the robot take back the wheel. It bridges the gap between total automation and human oversight.
Speaking of captchas, do these services actually solve them? Or am I still going to be clicking on pictures of traffic lights for the rest of my life while my intelligent agent watches me like a confused puppy?
It is still a battle. Some platforms have integrated CAPTCA solvers that use AI to identify the objects or bypass the "I am not a robot" checkbox by simulating human-like mouse movements, adding a bit of jitter to the cursor so it doesn't move in a perfect robotic straight line. But the top-tier protection, like Cloudflare's Turnstile or the latest versions of reCAPTCHA, are specifically designed to detect the subtle timing patterns of automated browsers. No SaaS can honestly claim to solve 100% of these challenges forever. It's a constant arms race.
So the SaaS value proposition isn't that they have a magic skip button for Cloudflare. It's more that they're the ones staying up all night updating their stealth plugins so you don't have to. You're paying for their maintenance team. If a new detection method drops on a Tuesday, they have a patch by Wednesday.
Precisely. If you use the open source Playwright Stealth plugin, it might work today and be broken tomorrow because a major site updated its detection script. If you use a service like Browserbase, their entire business model depends on their browser staying undetected. They have a team dedicated to reverse engineering the latest anti-bot techniques. For a developer, that peace of mind is worth the platform fee.
Let's talk about Steel for a second. You mentioned them alongside Browserbase. How do they differ? Because if everyone is just offering Chrome in the cloud, it feels like a race to the bottom on price. Is there actual differentiation here, or is it just brand names?
There is differentiation in the last mile of the data. Steel is interesting because they are leaning heavily into the agentic framework side of things. They make it very easy to plug into tools like LangChain or any Model Context Protocol (MCP) setup. They also focus on structured data extraction. Instead of the AI agent having to parse a messy HTML page full of ads and sidebars, Steel has tools that can help turn that web page into clean JSON data that an LLM can actually understand.
That makes a lot of sense. Most of the brain power of an AI agent is currently wasted just trying to figure out which part of a website is the actual content and which part is a sign up for our newsletter pop-up. If the browser layer can handle the cleaning, the agent can focus on the reasoning. It's like pre-chewing the data for the AI.
Right. And there is a new standard Daniel mentioned called MCP Model Context Protocol pioneered by Anthropic. This is huge for this ecosystem. It basically creates a standardized way for an AI model to call a tool. Browserbase already has an MCP server. This means if you're using Claude or a Gemini model, you don't have to write a bunch of custom glue code to connect it to a browser. You just say, "Here is the MCP server for my browser," and the model natively knows how to spawn a session, navigate to a page, and read the content.
It's like giving the AI a standardized driver's license for the internet. It doesn't matter what car it's driving. Playwright, Puppeteer, a cloud instance. It knows the rules of the road. But I want to push back on the cloud is always better narrative. If I'm a developer and I'm just doing some basic web scraping or running a few automated tests for my own app, isn't it overkill to pay for Browserbase?
Oh, for testing, local is still king. If you're a developer and you just want to make sure your submit button works on your own website, you should absolutely run Playwright locally. It's free, it's fast, and you don't have to worry about anti-bot detection because you own the site you're testing. The cloud service has only become necessary when you are dealing with the open websites you don't control that are actively trying to keep you out.
So, local for testing, cloud for questing. If your agent is going out into the wild to do battle with the internet, it needs the cloud-hosted backup. But what about the latency? If I'm running a browser in a data center in Oregon, and my agent is running in a data center in Virginia, doesn't that add a lot of overhead to every click?
It can. One thing people don't realize is the latency. If your AI agent is in a loop where it needs to click something, wait for the page to change, read the text, and then decide its next move, doing that over a WebSocket connection to a remote browser adds a lot of lag to the agent's thought process. You're sending a command, waiting for the browser to execute, waiting for the DOM to update, and then sending the result back to the LLM.
Right. If every thought the agent has requires a round trip to a server in a different state, it's going to feel very slow. It's like trying to play a video game with a 3-second delay. You're going to keep running into walls. How do the platforms solve that?
Some of them are moving the intelligence closer to the browser. Instead of sending the whole HTML back to the LLM, they run small local models at the browser edge to summarize the page or identify the next likely action. This is where visual grounding is becoming so important. This is a trend where instead of the agent trying to read the HTML code, which can be tens of thousands of lines of messy divs and spans, the browser takes a screenshot and uses a vision model to identify where the buttons are. It says, the Buy Now button is at coordinates x500, y200.
That sounds much more resilient. If a website developer changes the name of a CSS class from BTN primary to BTN purchase, a code-based scraper breaks immediately. But a vision-based agent just sees a big red button and says, "Yep, that's the one I want." It's more like how we actually use the web. We don't read the source code to find the login button, we just look for the word login.
And that is where the browser layer starts to look like an operating system. If the browser can provide these coordinates and visual metadata directly to the AI, the agent doesn't even need to know how to code. It just needs to know how to see. It simplifies the entire stack.
We've talked a lot about the technology, but I want to touch on the ethics and the cat and mouse game from the website's perspective. If I'm a small business owner and I have a website, and suddenly a fleet of thousands of browser-based powered AI agents starts crawling my site, using up my bandwidth and scraping my data, I'm going to be pretty annoyed. I'm going to want better bot detection. Are we just making the internet unusable for humans by flooding it with invisible browsers?
That is the cycle. As the stealth tools get better, the detection tools get more aggressive. We are seeing a move toward what people are calling the agent-first web. Some sites are starting to realize that they want AI agents to visit them, maybe to index their products or provide information, so they are creating machine-readable versions of their pages.
Like a robots-only entrance to a club. If you're a human, go through the front door and look at all our pretty ads. If you're a robot, go through the side door and we'll give you a nice clean JSON file. That seems like the only way to avoid a total war between scrapers and firewalls.
We actually talked about this concept of the agentic internet in a previous discussion, the idea of a clean web for machines. But until that becomes the global standard, headless browsers are the only way for agents to navigate the messy web built for humans. And the messy web is where 99% of the useful data still lives.
Which brings us back to the competitive landscape. Browserbase versus Steel. Who wins? Does it just come down to who has the biggest pool of residential IPs or the lowest prices?
I think it comes down to context management. The winner won't just be the one who runs the best version of Chrome. It will be the one that manages the agent's memory the best. If a platform can handle the file uploads, the downloads, the persistent logins, and the complex navigation flows so the developer doesn't have to, that is the sticky product. Think about how complicated it is to download a PDF from a site, parse it, and then upload it to another site. If the browser service can do that natively, that's a huge win.
It's the infrastructure play. You want to be the pipes that the AI's thoughts flow through. If you control the browser, you control the agent's interaction with the world. You're the gatekeeper between the model and the internet.
It's a high-stakes game. If you're a developer building an agentic startup today, you're looking at a world where you can either spend 6 months building your own browser infrastructure, managing proxy rotations, and fighting Cloudflare, or you can plug into an API and have a stealth browser ready in 5 minutes. Most people are going to choose the API.
I'd choose the NAP, but that's just me. I can definitely see the appeal of offloading the fingerprint rotation headache to someone else. It's like the early days of Stripe for payments. Nobody wanted to deal with the security and compliance of credit cards, so they just paid a small fee to let Stripe handle it. Now we're seeing Stripe for browsers.
That is a great analogy. And the implications are huge for things like privacy too. If an agent is browsing on my behalf, is it sharing my real fingerprint or is it using a generic one? These platforms become the privacy shield for users as well. They can effectively anonymize your browsing by making your agent look like a completely different person every time.
Or a privacy risk. If the platform itself is logging everything your agent does. If I'm using an agent to do my banking through a third-party headless browser service, I'm basically giving that service the keys to my vault. They see the login, they see the balance, they see the transfers.
That is the trust gap that these companies have to bridge. They need to prove that their environments are secure, encrypted, and that they aren't peeking at the session data. Browserbase, for instance, emphasizes their secure sandboxes, where each session is isolated and the data is wiped after the session ends, unless you specifically choose to save the state.
Let's get practical for a minute. If I'm a listener and I want to start playing with this, what's the starter pack? How do I go from clueless human to master of a robot fleet?
Start with Playwright on your local machine. It's a fantastic library, the documentation is excellent, and you can get a script running in about 10 lines of code. Use it to automate something simple, maybe a script that checks a local store for a specific item and sends you a notification, or a script that logs into your electricity portal and saves your monthly usage to a spreadsheet. Once you hit a wall, once you get blocked by a site, or you realize your laptop is melting because you're running too many instances, then look at the cloud providers.
And don't forget the stealth plugins if you're staying local. They aren't perfect, but they'll get you past the low-level detectors that are just looking for the word headless in your browser string. It's a good first lesson in the world of digital disguises.
And if you're building an AI agent specifically, look into the MCP servers we mentioned. Being able to connect a model like Claude directly to a browser instance without writing custom scrapers is a game changer for speed of development. You can literally just give the model the tools to use a browser, and it will figure out how to navigate the site on its own.
It feels like we're approaching a point where the web, as we know it, this visual, ad-heavy scroll fest, is going to become a background process. We'll just ask our agents to go get me the best deal on a blue sweater, and the agent will spend its afternoon fighting Cloudflare and rotating fingerprints on a headless browser in the cloud, while we just wait for the notification. We won't even see the websites anymore.
That is the dream. But as a nerd who loves the technical details, I find the fight just as interesting as the result. The way these anti-bot systems look for tiny timing discrepancies in how a browser renders a single pixel, it is a level of forensic digital detective work that is just fascinating. It's a battle of wits between the best engineers at Google and the best engineers at these security firms.
You call it fascinating. I call it, I'm glad someone else is doing it. I think the takeaway for me is that the browser isn't just an app anymore. It's a service. And as AI agents become more prevalent, the demand for these stealthy, scalable, cloud-hosted browsers is only going to go up. It's the new utility.
It is the shovel in the AI gold rush. Everyone is building gold miners, the agents, but the people making the shovels, the browser infrastructure, are the ones who are going to be essential regardless of which agent wins. If you want to build the next great AI assistant, you need to know how it's going to talk to the web.
Well, I hope the agents remember to tip their browser providers. This has been a deep dive into a part of the stack that most people never see, but that literally every AI agent depends on. It's the plumbing of the intelligent internet.
It's the invisible infrastructure. And as Daniel's prompt points out, it's becoming the most contested territory in the AI world. Whether you're using Playwright for local testing or Browserbase for global agentic questing, the browser is how the AI meets the world. It's the lens through which it sees our digital reality.
And hopefully the world is ready for it. I think that's a good place to wrap up the technical deep dive for today. I learned that I'm probably being tracked by my GPU's unique way of drawing a square, which is a terrifying thought to end on.
We covered a lot of ground, from fingerprinting and residential proxies to the human-in-the-loop handoffs and the rise of MCP. It's a complex ecosystem, but it's what makes the agentic future possible.
Thanks as always to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power the show and allow us to run our own experiments in this space.
If you found this useful, or if you're currently fighting a Cloudflare challenge that's winning, reach out to us. We'd love to hear your war stories from the headless browser front lines. There's a whole community of people out there just trying to make robots behave like humans.
You can find us at myweirdprompts.com for the RSS feed and all the ways to subscribe. If you're enjoying the show, a quick review on your favorite podcast app really helps us reach more people who are curious about these weird tech niches.
This has been My Weird Prompts. I'm Herman Poppleberry.
And I'm Corn. We'll see you in the next one, hopefully without any captures standing in our way.
Goodbye for now.
Take it easy. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes